Take out your highlighter. Characteristics 2 and 3, horizontal and oblique asymptotes. So what's going to happen with horizontal and oblique asymptotes? Well, with the horizontal asymptotes, that's what's happening as x gets really, really big. And again, the technique of looking at the highest degree will be a shortcut for us for determining what kind of asymptote we're looking for. So in this case, what is the highest degree in -4 over x plus 4? It's the 1, it's the x. If you look at your x's then, well, on the bottom I have 1x. How many x's do I have on the top? 0. Does this fraction simplify? Yes, it simplifies to 0. So this one will have a horizontal asymptote at 0. Anytime the fraction that you make with your highest degree simplifies to a number, then you will have a horizontal asymptote. When it doesn't simplify to a number, it means that you either will have a whole or an oblique asymptote. So here's our first one. It simplified to 0. Sure enough, it has a horizontal asymptote at y equals 0. What they're looking at in the notes here, they're saying if I put a very, very big number in for x, I would have -4 divided by like a billion. That's going to be very, very close to 0. So here is another one. 2x minus 3 over x minus 1. In your textbook, they go through a synthetic division idea to look at this. It's going to be easier for us to use our same technique. What's our highest degree? 1. We have 1x on the bottom. We have 2 x's on the top. Does this simplify to something? It simplifies to 2. Okay? So we're going to have a horizontal asymptote at 2. This is a nice explanation. We're not going to go over it right now, but it allows you to rewrite your equation, 2x minus 3 over x minus 1, and learn how to rewrite that as 2 minus 1 over x minus 1. But we're not going to worry about that. Again, the exam is not going to focus too much on oblique asymptotes. So for us right now, this is going to be just fine. And how do we know when there's an oblique asymptote? If we look at this third example, x squared over x plus 1, the highest degree is x squared. How many x squareds do we have on the top? 1. How many x squareds do we have on the bottom? None. This doesn't simplify. It's not possible. Any time that it's not possible, it's going to mean that you're going to have an oblique asymptote. It might mean you have a hole in your graph, but you're going to want to check first if something simplifies. For example, let's say I have this equation. Can you see that you would have an x squared on the top and no x squareds on the bottom? Which would make you think, hey, it's not possible. Does that mean it has an oblique asymptote? In this case, no, because the x plus 1s would cancel out. And then you have a hole, and what you're left with is something you can graph. You know what the graph of x plus 2 looks like? You could graph it and draw the hole in there. But if nothing simplifies and you check your biggest degree and you get something that's not possible, it means that you're going to have an oblique asymptote. The hard thing about oblique asymptotes is labeling their equation. How do we label the equation of an oblique asymptote? It's not that bad actually, but you have to use your synthetic division. You actually divide x squared by x plus 1. Does it make sense that x squared has 1x squared, 0 x's, and 0 constants? And if you were dividing by x plus 1, you would put a -1 out front. synthetic division. Bring the number down, multiply, add, multiply, and add. And you get, as an answer, x minus 1 with a remainder of 1. Whatever you get as your answer, you can ignore the remainder. The remainder could be 8 billion. I don't care. Whatever you get as your answer will be the equation of your oblique asymptote. So it's not actually that hard to figure it out. So with that, we can go to example number 2. Use the equation to predict whether it has a horizontal or oblique asymptote. We're also going to look at vertical asymptotes or holes. So we're going to sort of do everything in each of these ones to get us prepared. Can you factor the top of A? You can try. Would you like me to try? Oh, x plus 7, x minus 1. Yay, it works. Nothing cancels out. So, first of all, from example 1 decided whether your non-permissible value, and we're sort of going to use this as a, I'm going to go through example 1 again and example 2, because when you get to graphing these, you want a system, a nice system for graphing them. The first thing you're always going to look at is your non-permissible values. In this case, x can't equal -2, and what do we know about -2? Is it going to be a hole or a vertical asymptote? It's going to be a vertical asymptote at x equals -2. After figuring out your vertical asymptote, you're going to look at your next asymptotes. Is this graph going to have oblique asymptotes or horizontal asymptotes? What's the highest degree? Look at the original equation, is an x squared. We have x squared on the top and no x squareds on the bottom. This is not possible. So that means we are going to have an oblique asymptote. So you'll always have an oblique asymptote unless you've had a hole prior to that that simplified the equation so that it no longer had a non-permissible value. How do we find the equation of our oblique asymptote? We find the equation of our oblique asymptote by doing synthetic division. So we have 1, 6, -7. Bring down the 1, multiply, add, multiply, add. Our equation of our oblique asymptote is y equals x plus 4. So it says use graphing technology to verify, but we are going to practice graphing right from the beginning. So how do we graph this now? Well, you always start your graph because the first two things we found were our asymptotes. We knew that there is going to be a vertical asymptote at x equals -2. So you can draw that asymptote in and label it. We also know that there's an oblique asymptote at y equals x plus 4. So we can draw that in because it's a line with a y-intercept of 4 and a slope of 1, so over 1. And label it as well with its equation. Once you have both of your asymptotes, now you can start labeling some points. It's always good to start with x-intercepts and y-intercepts. So, how do we find our y-intercept? Plug in 0 for x. If we plug in 0 for x, can you see that you're going to get -7 over 2? So we can label that as 1 point. For our x-intercepts, we find x-intercepts by making y equals 0, and it's always nice to use your factored form, because once it's factored, the only way a fraction is equal to 0 is if the numerator is equal to 0. So what values are we going to have? 1 and -7. If you end up, like we do in this case, having a point in both sections as separated by the non-permissible value. The non-permissible value separates your graph into 2 halves. And we have a point left of x equals -2, and we have a point right of x equals -2. We can now just finish by drawing the asymptotic behavior. So we know that in between these 2 points, they're going to have to be connected. So this has to go towards that asymptote, and this will go towards that oblique asymptote. This point here, it's going to go towards that one, and then a little bit of a bend in there. Pretty straight. It should be a nice curve, but sometimes things go awry. So that's how we could graph that one with oblique asymptotes. We're not going to get into ones where there's horizontal and oblique asymptotes, no. I mean, technically we could probably make something where that happened, but why would we do that? No, we're not going to have any of those. In fact, the majority of your questions are going to deal with ones that don't have the oblique asymptotes. Yes? Equation? Once you've done the synthetic division, what you get is your answer. So my answer right here says I get x plus 4 remainder -15. And you just use the x plus 4, and it doesn't matter how big or small that remainder is. That doesn't come into effect. Wait, part B. I'm going to erase part A. Is that okay? Any more questions about A? So for part B, x plus 2 over exactly the same thing. So since we factored this already, we already know that it's x plus 7, x minus 1. So we sort of notice that you're going to always want to factor things completely to begin with. It's going to tell us some important information. Now our non-permissible values, x can't equal -7 and x can't equal 1. Are those going to be vertical asymptotes, or are they going to be holes? They're both going to be vertical asymptotes. Vertical asymptote at x equals 1 and x equals -7. Next, if we look at the highest degree, since nothing's simplified, we can go to our original equation. Our highest degree is 2. We have 1x squared on the bottom. We have no x squareds on the top. What does this simplify to? 0. So we have a horizontal asymptote at y equals 0. Now, when you would go to graph this, again, you always start with your asymptotes. So we have an asymptote at 1. And we have an asymptote at -7. Hello.
Could Julia Hurd please be excused?
Yeah, she'll be right down.
Thank you.
So we can label these asymptotes at x equals 1 and x equals -7. We also have an asymptote at x equals 0. So now figuring out what is going to happen in this graph, well, let's label any intercepts if we can have them. Yeah, it's supposed to be y equals 0. Thank you, thank you, thank you. Save me from all those YouTube haters. No, and very rarely do I get a comment on YouTube. On this one. Not that I know of. I probably can count on my hand the 3 or 4 comments that. So, okay, so we've got both of our asymptotes. What we're going to do now is check for x-intercepts and y-intercepts. First of all, your y-intercept is easy because you can plug in 0 for x. Can you see that you'll get -2/7? Well, that looks like it should be right there. Perfect. Make a big dot. Covers all those points. 0, -2/7. That's our x-intercept. That's our y-intercept. Man, this is a bad video already, right? Okay. It's Friday. Do we have any x-intercepts? Well, if we look at the factored form, the only way we'll get an x-intercept in a fraction, yes, -2. So this feels a little bit weird, doesn't it? Because we have an asymptote at y equals 0, and yet we still have an x-intercept. That can happen because our asymptote at y equals 0, all horizontal asymptotes are just telling us what happens when x gets really, really big to infinity or really, really big to a negative infinity. Yeah, it's hard. Really, really big negative numbers. Okay, there we go. So we've got these 2 points so far. As far as what I can tell from this, I can tell that, oh, I want green. There we go. I can tell this much of my graph so far. Wonderful. I don't know if my graph is going to bounce off that -2 and go back down, or if it's going to continue up and go towards the asymptote. Okay? What we have to do is we have to plug in a few more numbers. So if we try -3, so if I plug in -3, I'm going to find out what I get. So here's my equation. If I plug in -3, does it make sense on the top? I'm going to get -1. And on the bottom, I have 4 times a -4, -1, -1 over -16. Oh, which is equal to 1 over 16. Are you okay with that? So we have this point, -3, 1/16. And since that point is above the x-axis, I now know that it has to go up like that. Because the only way it could go back down and hit this asymptote on the down direction would mean that I have another x-intercept, but I factor the top and I only have one x-intercept. It kind of looks like a cotangent graph. Cool. or a negative x cubed graph. But we're not done yet, because our asymptotes separate our graph into 3 sections. We have only graphed the middle section. We still don't know what's here or what's here. As far as figuring out those sections, again, you're going to have to plug in a value. I would try 1 bigger than, let's plug in 2. Let's go back to our original equation. Take out our pen, that disappears. If you plug in 2, you get 4. On the bottom, you get 9 times 1 is 9. You agree that it's 4 9ths? Good. So we have the point 2 comma 4 9ths, and once you know that it's in that section, this part of the graph is going to look like that. Well, the only way it would cross is if there was an x-intercept. And we found that the only x-intercept was -2, because that's the only place where our fractions equal to 0 at the top. Finally, we're going to need to find something in this first section. So I'm going to plug in -8. That'll give me -6 on the top. This will be -1 times -9, which will be 9. Yes? That's good? Didn't make any mental math errors? Excellent. Okay, so now we can go and plot that point in -8, -6 9. So you could reduce that to 2/3, but then that tells us this section is down there. That's a complicated looking graph. We can make a special name for this. What does it look like? Sadness? It's not sad. It's so pretty. It's kind of symmetrical and artistic at the same time.
Or we could call it death.
Death! You guys are wonderful. Oh. So positive. Actually, there is a name for this one. It's called roadkill. No, I'm just kidding. All right, 6 and 7.